Lesson 48 is all about polynomials, degree, and addition of polynomials. Now, a polynomial is an expression with one or more variables with numerical coefficients and whole number powers. Please take a moment to pause the video and copy that into your notes. Now, if we look at that definition in our example here, 3x squared, we know a polynomial is an expression with one or more variables. So we've got our variable. Our variable in 3x squared is the x. And then it says with numerical coefficients. So numerical coefficients just means number coefficients, and coefficients are the numbers out in front. So in red, we've got our coefficient in this polynomial of 3. And whole number powers. Well, we've got our whole number power. Our whole number problem in this 3x squared is the squared, or the second power. So we meet all those criteria for a polynomial. 3x squared must be a polynomial. Let's look at some other polynomials. Maybe we could have negative 4y to the third power. Well, that has one or more variables, y. It has a numerical coefficient, negative 4, and it has a whole number power of 3. What if we had negative 1/16 x, y, z to the second power? Well, if we had that, we've got the same criteria. This must be a polynomial as well. Let's look at one more. Let's say we have this, y. Y. Is that a polynomial? Well, the answer is yes. And it's a polynomial because it has one or more variables. There's our y, there's our variable. The numerical coefficient of y, well, we must have one of them. So the numerical coefficient isn't written because it's implied. It would have to be a 1 because we have 1y. And whole number powers. Well, we have 1y to the first power. So when we write y, we simplify it, but it's really 1y to the first power. So yes, y is an example of a polynomial. Let's move on to our next example. Here we've got some more definitions. Pause again if you'd like to get these into your notes. A degree of a term is the sum of the exponents of the variables in the term. So if we have x to the second power, our degree is going to equal 2 because it's to the second power. And a degree always talks about what power you have. So degree here equals 2. Say we have another one. Say we have yx to the second power. If we have yx to the second power, we know degree of a term is the sum of the exponents of the variables in the term. So y to the first, x to the second, that's going to give us a degree of 3. If we look at one more, say we have y squared x to the fourth z. Well, the degree is going to be the sum of the exponents in the variables of the term. 2 plus 4 is 6, plus 1 for the z is 7, so the degree would be 7. Now the other definition that we have down here is for degree of a polynomial. A degree of a polynomial is the degree of the highest degree term. And when we talk about this degree of a polynomial, we're going to add a part into this definition. Degree of the polynomial, and it's degree of a polynomial expression, to be very precise. So please add that in after the polynomial before the colon. Degree of a polynomial expression is the degree of the highest degree term. So let's say we have this. Let's say we have 3x squared plus 2x plus 7. Well, the highest degree term in this, well, x squared, because it's the biggest term. So the degree of this polynomial expression would have to be equal to 2. Let's look at one more. Let's say we have 4yz plus 3xy to the seventh plus 8. Now, the highest degree term that we have, okay, so this first term has a degree of 2, y to the first, z to the first. The second term has x to the first, y to the seventh, so the degree there is 8. And then the third term has no degree because there's no variables. So the highest degree term, well, the degree of this would be equal to 8 because of that term, 3xy to the seventh. Let's go ahead and look at some examples. What we want to do is add, and we want to write the answer in descending order of the variable. So if we're adding, first thing we have to do is we have to figure out how many x to the third powers we have. Well, we have 1 here, and we have 2 here. So we add 1x to the third plus 2x to the third. That must be 3x to the third power. Then we have to figure how many x squareds we have. Well, we have 3x squareds next, and we have no x squareds. So we're going to get a total of 3x to the second power. We can see we have no single variable of x, or x to the first, so we don't need to write that. Then finally we have plus 2 and plus 4. That must be plus 6 when we add them together. Now it says write the answer in descending order of the variable. Well, that means we want the biggest variable first, and then the second biggest variable second, and so on until we get the smallest. So 3, 2, there is no 1 in this one because there was nothing, and 0. So we've got our answer. We can go ahead and box it and move on to our next question. Okay, we need to add and write the answer in descending order of the variable again. This one it says add, but you can see we have subtraction. So if we add and we have subtraction, what we want to do is rewrite and instead of subtracting, we're going to add, but we're going to add the opposite. So we're going to distribute the negative sign through everything we have within our second parenthesis. So we're going to get negative x squared because we're taking the opposite, plus 7x because that's the opposite, plus 5. And now we can go ahead and find our answer. How many x to the third powers do we have? Well, we've got 3. We've got none. That makes it easy. We get 3x to the third. How many x to the second powers do we have? Well, we have 2. And we have negative 1. Well, 2 plus negative 1, that's just 1. So we're going to get plus x squared. We don't need to write the 1 out in front. That's implied. We have negative x, and we have plus 7x. Negative x plus 7x, well, that's 6x. So we get plus 6x. Then, next, we have our plus 4, and our plus 5, plus 4, plus 5. That must be plus 9. We're all done. We've written the answer in descending order of the variable. You can see the variables go 3, 2, 1, and 0. And we've added, okay, and we've added because we've distributed the negative through all of our things in our second set of parentheses. Lesson practice will be on page 195. Make sure you've got your notes complete, and I'll see you during our next class.